Really, there are three main types of probability. However, in this video, we're only going to talk about experimental and theoretical probability, how they differ, how we can compare them, and how we can use them. Experimental probability is probability that's based on repeated trials. To calculate experimental probability, we've used the same equation as what we would with relative frequency. In our last video, we learned that relative frequency can be calculated by placing the number of times an event occurs over the total number of times that we try. Let's take a look at one of these types of problems. Using the data recorded, what was the experimental probability of flipping heads? So we're looking at this table and we got heads 6 times and tails 19. So we want to know what was the probability of getting that heads. As a reminder, the probability is the number of times an event occurred over the total number of trials. How many times did they flip heads? That goes in the numerator here. So 6 versus the total number of times we tried. Taking a look at the table, we've got heads 6 times and tails 19, which gives us a total of 25 times. Probability can be represented as a fraction or a percentage. So to change this into a percent, we need to realize that a fraction is a division problem, and percent means out of 100. So we're going to take 6 divided by 25 times it by 100 to get 24%. A little bit of review of the likelihood here. This will be unlikely to happen according to this experimental probability. Theoretical probability. Theoretical probability is probability based upon the equality of all outcomes. Theoretical probability of any event, we take the number of favorable outcomes over the number of possible outcomes. Say we have some alpha blocks. Okay. We want to know what's the theoretical probability of choosing a vowel from the selected set. We have E, O, and here's another E. So again, the probability is the total number of favorable over the total number possible. Our favorable outcomes are all of the vowels. We have 3 different blocks, even though the E's are the same. We have 3 different blocks that could give us a vowel over a total of 7 blocks. This would be our theoretical probability. So theoretically, picking a vowel randomly, we have a 43% chance of doing so. Almost equally likely than picking a consonant. Comparing probabilities. Now that we know how to find the experimental probability and find the theoretical probability, we can learn how these two compare as we do trials versus what we expect would happen. For example, when we were talking about experimental probability, we did flipping a coin. And we found that 6 out of 25 times, heads was flipped. Theoretically, what was supposed to happen though? This gave us 24% chance of flipping heads. But theoretically, we only have 2 sides, and we only wanted heads. So we had 1 favorable outcome over two possible. Okay? Most of us understand that flipping a coin, we get a 50% chance. It's either going to be heads or it's going to be tails. Theoretically, sometimes that doesn't always happen. Let's say we did this experiment even more. Maybe instead of flipping 25 times, we flipped 100 times, or even 1,000. What could we expect to see? Ideally, the experimental probability will start to approach the theoretical probability as we do more trials. So right now, the experimental probability is almost half of the theoretical. But if we were to flip those coins more, we would see that experimental probability increase higher, closer to the theoretical probability. How do we use these probabilities to help us predict situations? Well, simply put, we're going to multiply the probability that we've calculated by the total number of outcomes that we think or that we know is possible. Here's an example. If I know that a bag has 50 marbles, and I pick a marble 30 times and put it back after every time, and we get this as a set of data. Blue 3 times, green 12 times, a red marble 9 times, and a yellow marble 6 times. We can now predict the number of red marbles that might possibly be in that bag. First, we need to find the probability of picking a red marble with what we have. We have 30 picks, and we picked red 9 times. So, reminder, the probability of any event is the number of times that event occurs over the total number of times we tried. The probability of picking a red, we picked it 9 times out of 30. Once we reduce that, we get 3/10, which is also equal to 30% probability. But now we have 50 marbles in the bag. We know we have 50 marbles. So can we guess how many red marbles there are? And the answer is yeah, sure, why not? Our probability that we calculated says that 3 out of every 10 marbles are probably red. So if 3 out of every 10 marbles are red, well, we're just going to say now there's 50. So we're going to take that and we're going to times it by 50. We get our prediction of 15 red marbles. How else might this be handy? Let's say our school has 420 7th graders, and 252 of those students are males or boys. If I myself have 90 students in my accelerated math class, can I predict how many might be girls? In order to do this, I'm first going to ask myself, how many girls are there total in 7th grade? I know that there are 252 boys and 420 total students. 420 minus 252 gives me an answer of 168. Now that I know how many girls there are total in 7th grade, I can find the probability of just randomly picking a girl student. There's 168 girls out of a total of 420. Once I reduce or simplify that, I get a probability of 2/5, or 40%. So 40% of the 7th graders are girls. Now that I found my probability of my event occurring, I can multiply that by 90 because I have a total of 90 students. If 2 out of every 5 of those students are girls, multiplying 2/5 times 90, I get a total of 36 girls. And that's my prediction, is to count on possibly having 36 girls in my math class. In this video, we defined the difference of experimental and theoretical probability, figured out how to find each of them, learned how to compare them, and how we could use them to help us predict certain situations.